So, of course, I'd like to start by saying thank you, everyone, for coming. My name is Cody Armstrong, and we are talking about multi-part modeling today. So, for those that have spent a bit of time in Onshape, maybe built a few parts here and there, but now you're trying to get into more detailed, more complex examples of building models. So, we're going to focus on multi-part modeling and all the various ways that multi-part modeling can be used. As I always say with these webinars, we really encourage you to ask any questions that you'd like. There's a questions dialog, and you go to webinar panel. Feel free to type in any question, and I'll do my best to stop and answer them from time to time. If I don't get to your question, stick around. I'll make sure after the webinar that all the questions are addressed. So again, thank you everyone for coming, and don't hesitate to ask any questions. Now, before I get into the topic of the day, there are a few things I'd like to mention about Onshape in general. So if you're just getting started, if you're new to Onshape, one of your first webinars, one of the first things I'd like to point out is our mission statement, and that is getting everyone working together with CAD on any device, anywhere. And this includes mobile devices. So if you haven't downloaded the Onshape app for either Android or the iOS, I definitely recommend it. You have a full-blown CAD editing tool on your Android phone or tablet or your iPad or iPhone. And it's not just a viewer. You can create sketches, parts, assemblies, all on a mobile device. So, and it's not just mobile. It's also Chromebooks, Linux, Mac, Windows. Any computer with an internet connection and a modern browser, you can get access to Onshape. So, everyone working together with CAD on any device, anywhere. That's our goal. Now, some other elements that I like to point out about Onshape. First off, we do consider ourselves professional 3D CAD. And when you think of professional 3D CAD, it's generally three pieces: parts, assemblies, and of course, drawings. And we do have all three major pieces that make up a professional 3D CAD system. Some things that are unique, however, is with Onshape you have built-in version control. It's not a separate add-on or a separate package that you have to refer to. It's integrated into the core of Onshape. So there's no data management software, nothing that you have to install or buy separately. With Onshape, that functionality is built into the core. Also with Onshape comes the ability to both import and export common CAD formats. So if you've come from a traditional CAD system, or if you've come from some other CAD system and you have this library of data, chances are we can import those CAD files. So some examples would be Step, IGES Parasolid, SolidWorks Inventor, Creo, CATIA, a number of different formats that we can import. And many of those we can also export. So this makes it a great tool for importing and storing your CAD data, maybe collaborating with others, a great tool to work alongside an existing CAD system. So if you have a library of data, and this also includes DXF and DWG, by the way, we work well with it. And also we have the ability to export many of those formats. So Step, IGES Parasolid, DXF, DWG, PDF, a number of different formats are supported. So read and write common CAD formats, a very important element of this. It means Onshape works well alongside your current CAD tool. The last thing I want to mention is with Onshape, we've introduced entirely new methods of collaboration. So if you haven't shared your document yet, I definitely recommend it. There's a share icon on the top right, and you enter their email address, define their permissions that you'd like to share with them, and hit share. It's very easy. They don't have to install anything. They click a link, and they're looking at the same model as you are. Even if they don't have an Onshape account, you can share with them. You have the option to share with just simply a link, and the person never has to create an Onshape account. Or if you want to give them ability to edit, we create an account for them on the fly. So the idea is to make it very easy to share. So if you haven't already, definitely share your document. It's very easy to do, and you get a lot of benefits from it. And one of them is the ability to real-time collaborate, simultaneously work together on the same model at the same time. And that's something that's never been done before in traditional CAD systems because, again, many of those systems are file-based. So entirely new methods of collaboration, real-time, simultaneous editing, comments, follow mode, all these neat capabilities that really help, those CAD users out there work together. So these are just a few things I like to mention about Onshape for those new users or for those just getting started with it. Now, what are we going to talk about here today? As I mentioned before, we're really going to get into multi-part modeling. What is it? Where would I use it? Why would I use it? What are the benefits to doing this? So I'll first introduce you to multi-part modeling. What is, in general, what is it, and why would I use it? So I've come up with 5 examples now. Understand that there are many, many examples I could give you, but I try to highlight what I think are probably the 5 most common examples of multi-part modeling. As always, I like to show how to import. So if you have data that you would like to import on Shape. Maybe you have some models you'd like to import from another system. I'll walk you through that as well. And again, like I mentioned before, feel free to ask any questions that you'd like. There's a questions dialogue. You can go to webinar panel. I'll do my best to answer any questions as we're going through this. All right, so let's get into it. Now, what is multi-part modeling? It's pretty straightforward, and I imagine most of you out there are aware of it. It's just multiple parts built together, but they're built together in the same part studio. And oftentimes, you'll hear the term top-down modeling, or you'll hear the term in-context modeling. There's a number of different names for it, but essentially what you're doing is you're building parts with contextual relationships to other parts. You're building parts around other parts. And this makes building things very easy rather than building one part in its individual space and then building another in its own space and having to take a number of measurements. It's very easy to constrain and attach parts to each other. So multiple parts built together in the same part studio. And there's a lot of reasons to do this. Probably the most common is just it's useful for creating dependencies. So if I had a certain design and I maybe designed 4 or 5 different versions of it, I don't want to have to change, a dozen different dimensions when really I'm only changing one value, right? I change it in one place, and because there's multiple parts that are dependent on each other, they all update, right? So it's useful for creating dependencies in multiple part scenarios. But there's a number of powerful multi-part techniques I want to cover. The most common is going to be just building multiple parts with references or dependencies to each other. But there's lots of examples where you might use a multi-part as a tool, or you might use it in a number of different situations. So let's get into that. Now, what else would you do? Probably the most common, and it's one of the most used techniques, and many users aren't even aware, is what's referred to as bridging. And bridging just simply means I'm taking a part in space and another part in space that are not attached in any way, and I'm creating some feature that bridges those two parts, right? Creating one. This is a technique that many users have done without even realizing it. All right, so bridging is a very common one. I'm going to show you a simple example of that. There's not much to it, but there is one thing to point out that's pretty important when we talk about bridging. But then we get into the real meat of multi-part modeling, and that is building parts with relationships to each other. So if I'm building, a suspension system, or if I'm building a clamp and I have, all these parts that are interdependent on each other, they're referencing each other, multi-part modeling just lends itself to that. So building parts with relationships to each other. The last example I want to show you here today is multi-part modeling as tools. So using parts as tools to form your finished part. I'm going to go over an example of that in just a bit, but it's definitely a powerful capability within Onshape, the ability to create a tool as a part and then subtract it or add it or merge it with other parts. So these are just a few examples. I have a few that I'm going to get into, so let's jump into it. All right, so the first one, bridging. Now, this is probably one of the most common examples in CAD that I can give you, and that is, you have a part on the left, you have a part on the right, but nothing is joining them, right? So it initially, when you create it, it's two separate parts. And here's a good example of it. I have a squeegee, and I have the handle, and I have the actual squeegee itself. Now, what I need is a feature that joins the handle to this cylindrical boss of the actual squeegee. So right now, these are two different parts. This is a multi-part part studio, and initially my handle is in two different pieces. And I think the thing for new users to understand here is you do not have to work in one direction or another. Oftentimes users say, I have to work from left to right or right to left. That's not the case. You can build parts that are initially separated and then later bring them together with what's often referred to as a bridge. So let me show you an example of this. I have the handle, I have the piece that it needs to merge with, but I don't have the joining feature. In this case, it's going to be a simple loft between the face and sketch 16 here. Now, let's choose the sketch. Here we go, sketch 5. Now, initially, what I want to point out here is that when you first do this, it's not going to default to merging them. Okay, so there's the joining loft. And by default, you'll see it's a different color indicating that it's a different part. And you'll see the option here for new. So that's really the key piece of this. By default, it assumes you want to create a new part. But what I actually want to do is add this feature to an already existing part. Right? So I choose add in the feature. And here's the important bit, and the bit that you have to understand when we're talking about merging features together is merge scope. What do I want to merge this feature with? What parts? And if you think about it, we have the handle and what the handle attaches to. Right? So I want all three of these parts, what would be independent features, merged into one piece. So that's where merge scope is important. Okay, so I think that's the key thing when we talk about bridging, like in this example where you have a feature over here and you have a feature over here and you want to join them together. Make sure to define it as add and define the merge scope appropriately. And again, what do you want to merge into one? Right, that should be highlighted in your merge scope. But again, if I don't choose this and I go back to new, you'll notice that now I have the handle, I have the piece that it's mated to, and I have a whole separate part in the middle. Right? So it's creating a whole new part in the feature list, okay, just by choosing new. So again, add, select the parts you want to merge with, and now the handle is one piece. Right? If I hide these two other parts, you'll see that handle is just one piece. Okay. So that's the idea behind bridging. And again, the key thing I think for new users to understand there is you do not have to work from left to right or right to left. You can build independent features at first and later join them. And there's nothing wrong with that technique. It's a very common one referred to as bridging. The important thing to understand is for a moment, for a period of time, they will be multiple parts until they're bridged and brought together. So that's an example of bridging, a very simple one, but it's important to understand. And that's probably one of the most common multi-part techniques. Many people do that and don't even realize that there is multiple parts in the part studio, right? Just because it's very easy to do. The next example I want to give you, and it's probably the most common example and probably one of the most powerful techniques, and that is building parts with relationships to each other, building contextual relationships between parts. So here I'm going to jump into, real quickly, a cantilever clamp assembly. Right? And if you look at something like this, there's a lot of parts with interdependent relationships. Right? So if I look at the arms, they have pinhole locations. The pinholes mount to these clamp arms. So you have all these various pieces that are related to one another. And many users out there today will still model each part in its own independent space. And there's nothing wrong with that approach, but you have an alternative. You have something that can be very fast, and that is multi-part modeling. So let me give you an example. Now, this is the finished assembly, right? So this is the finished arm with everything attached to it. But if I jump into the part studio that created this assembly, you'll notice that I actually have 10 parts in this one part studio. Right? So I have the arms, I have each of the clamps or blocks, I have the threaded rod to go through and drive it, and it's all been modeled together. And the important thing there is I'm not doing a lot of measuring between points and then transferring of dimensions between values. It's very easy to build all these contextual relationships in. So this is probably one of the most powerful multi-part modeling techniques that we have. And let me show you why. Let's jump into a new tab. Right? So this is, again, the finished part studio that drove that assembly earlier. Here is the sketch that drives everything. And so the idea behind this is I have one sketch called main sketch that really drives not just the arms, but the pins and a number of different components. So they're all driven from this one sketch. Now, there are a couple of key things to keep in mind when we do this. And one of the first is with Onshape, you can extrude any piece of a sketch or the entire sketch. So if I select extrude and I just select the sketch from the feature list, it assumes that I want to extrude the entire sketch. Right? However, I don't have to do it this way. I can X out of this selection and select individual pieces of the sketch to extrude. Okay, so you can extrude any piece of this sketch as its own feature. Now I want to set the extrude depth. We'll set this to 0.1. And then I just select faces within the sketch that I want to extrude. Okay, so again, I'm not limited to choosing the entire sketch or breaking things into pieces within my sketches just to satisfy the requirements of an extrude command. So there's my first feature. And you can see it's really just essentially half of that first sketch. And if I hit the green check, okay, there is extrude 1. What's neat about this is I can go right on and create another feature based off of this main sketch. So with Onshape, I can use a single sketch to drive as many features as I would like. So I'll select extrude. Again, we'll set the depth 0.1, and I'll just start selecting the faces to extrude. Okay. So the idea behind this is, again, you can use any piece of a sketch or the sketch in its entirety to drive parts. Again, the key thing to keep in mind is, at least by default, you'll notice it assumes that I want to add or merge this feature with the last one. So you'll see it's actually joining it together and it's the same color. But in my case, I want a separate part out of this arm. I do not want this to be merged with the original. So instead of setting this to add, I'm going to set it to new. And you see, as soon as I do that, now I have part 2. So this is the second part, and that's really the key. You're creating a new part, and you'll see that part added to your feature list. I'll reverse direction, and there is my second arm. Okay. So now I have 2 parts, 2 different extrude features, driven from one sketch. Right? And of course, the neat thing, and I think the reason that you would go down this road is it now makes it very easy to make changes. I can build a new clamp by changing 2 dimensions in one sketch, and all the parts automatically update. So I'll show you an example of that in just a bit, but let's take this one step further. I want to build a series of pins. So what I'd like to do is just create 2 sketches. Okay? And really what I'd like to do is just attach these 2 sketches to my first sketch. Right? Again, I really want that first sketch to drive everything. Okay? So I've created 2 circles. I'm constraining them to the first sketch. Right? So they are attached. And I'll hit the green check. So that's my first sketch, and it was on the top of this arm. Now I'd like to create a whole nother sketch, a separate sketch on the top face of the bottom arm. So I left click, we'll create a new sketch, and I want to sketch 2 circles. And I want to constrain them to the original sketch. Again, the goal here is making sure that first sketch drives everything. Now, one other thing I want to point out. A commonly asked question, well, what if I want 2 parts equal to each other in length or size? And how do I do that? Or what if I want these 2 parts tied, so if I change one, the other updates? Well, if you remember, we're modeling our pins for this clamp, and these 2 pins should have the same diameter. Because of the way we're modeling this, it's really just a matter of doing a sketch relation between this circle and this one. Right? So I can select this circle, this one, I can set them to equal, and now this circle's dimension drives this one. They'll both be the same. So if I change one, the other automatically updates. Now it's important to point out this works well because these 2 are on parallel planes. Right? The equal constraint will, sets them to an equal value, assuming they're on parallel planes. But if you're using, a different scenario where maybe they're not on parallel planes, you might consider something like a variable. But the neat thing about that is now they're tied. Both pins have the same diameter, and if I've changed one, they both update. So let's recap. I have 2 sketches, 4 circles on 2 different planes. Remember, this one's on the lower arm, this one's on the upper arm. Now I'll go back to extrude. I'll select both sketches, and now I'm extruding 4 parts at once. Right? So I don't have to extrude them independently or give them names independently. You don't have to do any of those types of things. You just select the sketches, and if there are multiple contours, it'll automatically assume that you want several parts. So it's very easy for me to extrude all 4 pins at once. Let's reverse this around and say up to a face, and we can use the mid-plane. And so now I'm extruding all 4 pins at once. And the neat thing about them is they all have the same in condition. If I change the in condition or if I change the plane location, all 4 of these pins will move at once. Okay. So I hit the green check OK, and now we've gone from 2 parts to 6 parts, right, including all of the pins. So now, again, the pins locations are dependent on the reference or the dimensions of the arms. If I change the original sketch, the pin locations will also change with it. But there's a number of different benefits to this that are outside of the realm of just simply updating or dependencies. One of the biggest is because I've modeled these pins with relationship to the arm, I can subtract one from the other, right? And that's an operation often referred to as a Boolean. So you can choose a Boolean, for example, and the option to subtract, and choose your tools, which in this case would be the arms, and then the targets. And it will subtract the tools from the pins, or the arms from the pins. So you see from the preview there, I am actually cutting these pins to match the arms. So I don't have to, again, figure out the dimension, go back to a separate tab or separate space and modify that dimension. I can just simply subtract one from the other. An important thing to keep in mind with Booleans is, by default, the arms, or the tools in this case, are not kept. They're strictly used as tools to subtract from another part. But in this case, I want to keep the arms, so I'm going to check Keep Tools. Okay, green check. And if I hide the 2 arms, you'll notice the pins are now cut to match the holes in the arms. Okay, so it's a very easy way to manipulate a part based on the geometry of another. Right? Question: when you use one extrude feature on 2 separate sketches, do they have to be on parallel planes? That's a very good question. In the case of some features, yes, they need to be in the same direction. But in the case of like a whole feature, which I'm going to cover here in a second, it does not. So I would say for the majority of the commands, yes. There are rare exceptions to that, though. Okay, so we have our 2 parts. Okay, and another example of a Boolean is something like a mirror command. So I can mirror these pins, for example, and I can say, okay, let's mirror all 4 pins, and we'll mirror them about the mid plane. And what's neat about this is you can automatically merge them, right, and select all 4 pins. And now I've mirrored the pin to the other side and merged it all in one piece, right? So you can build in the Boolean operations in mirrors or linear patterns or circular patterns. The important thing to keep in mind is in that command, you have the same new, add, remove option. If I wanted to add or merge this with the previous feature, that would be an add. If you wanted to cut or remove, you would have the remove option. Okay? And then also, by the way, if you only want the intersecting bodies between them, that's intersect. But again, just another example of the Boolean, I can flip the part or mirror the part and merge everything together in one shot. Question: how would you build in tolerances to those features? It's important to understand that tolerances themselves, the actual dimension that references the plus or minus 5,000ths, let's say for an example, is done in the 2D drawing level. However, what you can do is in the Booleans, you can actually add in a small offset. So if you're just referring to, I want a 5,000ths gap between these, I can offset the face 5,000ths, and that would give me that a slip fit, for example, versus a press fit. But if I want to specify tolerances for the purpose of manufacturing, that's done in the 2D drawing, and you can modify a dimension to do so. So forgive me if I'm not answering that question correctly, but you have the option to offset if you just want to do a simple offset to the geometry, but if you want to specify a tolerance, you'd have to do it in a drawing. All right, so that is the very first example that I have for building parts with contextual relationships. And the question may come up, well, why go through this effort? It is a little bit faster, and it certainly is. I didn't have to take a ton of dimensions to figure out where all these points go. But why would I bother with this? And one of the biggest benefits of doing this is now, as I mentioned before, one sketch really drives multiple parts. And this could be, there's really not a limit to this. You could have hundreds of parts referencing a single Part Studio. And that means that when I make a change, so I just changed 2 dimensions, everything automatically updates. So you'll notice the pin locations that I didn't have to shift them around because the references they were attached to moved, they moved as well. Okay. So again, that's probably one of the biggest benefits to building this way is it's very easy to change. If you need to make a iteration to it, you can change 1 or 2 dimensions and many different parts will change with it. Okay. And I think, for the new user, this is difficult to understand because you're used to building in independent spaces, but know that when you make a change and you're working in independent spaces, that often means that you need to go to each individual space to make a change to have everything work together. Right? And so the idea behind this is it's one place where you build everything in the same spot. So that is building parts with contextual relationships. Now I have another example of this. Actually, I have a few different examples of this. And the next one is what I call a multi-part whole. And it's just an example where you may want to create features where I use the part as a tool to shape or form other geometry. And this also answers another question that I get quite often is there a way to tell if one part is overlapping with another? If I failed to create a feature to accommodate and the two are overlapping and hitting, so to speak. So how do I find that? How do I find, those kinds of issues? So one of the first things I'd recommend is the section view command. So I'm going to select the right plane here. And in the view cube, at the very bottom, you'll see section view. So I just selected the right plane and I'm sectioning down the right plane. And one of the first things that you see is a bright red section of this bolt. Okay. The bright red indicates overlapping parts or interfering parts, right? So the question often comes up, can I tell if parts are interfering? When you do a section view, you're going to see any interfering parts show up in bright red. So that's the problem. How do I solve for that? How do I handle these kinds of issues? And again, if these were in 2 independent tabs, I would have to cut the thread and then come back and figure out what the dimensions are and mate them appropriately. But because I've built everything together, let's turn off section view, I can do a simple Boolean. All right, so I can select Boolean, subtract. I can subtract the tool, which is the bolt, from the target, which is this end cap. Okay? And again, I want to check keep tools to make sure the bolt is kept. But the important thing is now I'm subtracting the threads from the end cap. So again, one more time, let's do a section view down the right. Right. Now, a quick question. When building lots of parts in the Part Studio, the feature list on the left gets large and cumbersome. Is there any way to manage it, maybe like nesting features on the part after the fact? This is definitely something that we're working on. It is a way to organize the feature list, the Part Studio, even the tabs within the bottom of the interface is a way to organize it. Right now, there is not a way to nest or any kind of a folder structure that you could do. One tip that I would give most users is the search capabilities. If you give your features names, the search can help filter through them. But this is definitely an area that we hope to improve in the near future. Okay. So just keep that in mind. Another example of this would be many tabs in a document. That's another example we hope to improve search experience in a number of different things. So again, just jumping back into my model. Now when I do a section view, notice again no bright red. That's the obvious thing. But what's happened here is it's actually cut the end cap with the threads. It's subtracted the threads from the end cap. Right? So again, this is another example where I'm using a part both as a part with a contextual relationship, this bolt, but also as a tool. Right? So it kind of has a dual purpose. I'm subtracting it from the part as well. Okay. Now, another neat thing that we can do with this, let's go back. I'm going to delete that Boolean, is I want to pattern this bolt all the way around. Because we're in a Part Studio, we can very easily do something like a circular pattern of the bolt, right? So that I can easily select the part, say pattern this X amount of times, and I get it. Okay, real quickly, question. In these cases of booleans, it seems subtracting is line to line. If you want to build accurate CAD data, you want to build in offsets. How do you control that? As I mentioned before, let me jump back to my example. In the boolean, you have an offset, and you set the offset value here, right? So I can set individual faces to offset. So if I wanted a small gap between the faces, it's just a matter of checking offset. I can say offset all 5 thousandths, right? And now there's a 5 thousandths gap between the two diameters. Okay? So again, if you want a small offset between them, it's a checkbox. All right, so moving on. I mentioned before patterns. So because we've built all these parts together, I can take this bolt, for example, and circular pattern it around the entire retainer. So I can select circular pattern, select my entity to pattern, which is the bolt. Axis of pattern could be any cylindrical reference that has the same center. So we'll select the edge of the seal retainer here. And then I just find the number of instances and the spacing. So we'll say 360 degrees, and I want 5. Let's do 6. Right? So now I have 6 instances of the bolt in this part studio. I can hit the green check, and there they all are. And now I can go back and again do the Boolean and subtract all 6 bolts from the end cap as opposed to just one, right? Okay, real quickly, question. Will the offset apply to all surfaces? Any surfaces in that example, because it's using a 2D sketch, it's just offsetting the circles in those sketches. So if the question is it offsetting from the ends? No. Again, it's just extruding in this case, or it's taking an offset of the simple extrusions. So it would only be offsetting the diameter of those pins in that example. Okay, so I have all 6 instances. Now I can do a Boolean subtract, and again, use the tools. This time I'm going to have several tools, right? Every instance of the bolt. Okay, and then of course the target is that end cap. Okay. And again, I want to make sure to keep the tools because in this case, they are important to my design, right? The bolts are critical in the design. So I hit the green check, and now I've subtracted all 6 bolts from that end cap. Okay. So just to verify here, what we can do is again use this as a Boolean tool, as a way to pattern and then subtract to get the final end result. And the idea here is, if this end cap was in a different space and was in a different tab, I would have to then go in manually and create each one of those whole instances. So now if I do a quick section view, you'll notice that the threads are cut in both top and bottom. Okay, again, because I subtracted all 6 bolts from that end cap. So that is a simple example, again, of using not just multi-part modeling to build parts with contextual relationships like these bolts, but also using them as tools. So it kind of has a dual purpose. Now, there's one other thing I want to point out about this, and it's another big advantage to multi-part modeling. Here I have a pneumatic cylinder. 36 parts are modeled in one part studio. Okay? And one of the biggest benefits to this is actually when it comes to an assembly. So it's a bit of a tangent, but if I create a new assembly here, when you create assemblies and you insert multi-part part studios, they automatically can come in together. Right? So when I select insert, you'll see I have the entire cylinder, and I can select any piece of the cylinder, any individual part within it, or the entire cylinder in one shot. Right? So now I can insert all 36 parts into the assembly in a single command. And not only can you insert them all together, but you can also group them so that you don't have to add a series of mates. right? So that's the other commonly asked question. Okay, I've inserted all these parts. They all come in automatically together. But then when you try and move something, it all kind of, moves with it, right? It's free floating. So a tip is you can then group and select all the parts that you want to group together. Right? In this case, I have a number of parts that are static. They don't move at all, or they move with relationship to other parts. So here's all the tie rods and end caps and nuts and bolts and things that don't move. I'm just going to group. I don't need to bother with creating individual mates to mate each bolt to its location. I can just simply group them together and they act as one piece. And the neat thing about this is if you build these parts together and then you build your assembly, oftentimes very big assemblies can have one or two mates, because the mates really reflect how much motion there is. Everything else will be grouped, right? And so now, if I drag, you'll see all those parts move together. Okay? And so I can take some time, go through and define, okay, here's all the parts that are grouped that don't move, and I don't need to bother with mates. I can just group them, add maybe one or two mates to define the motion, and my assembly is done. So there's a big advantage to multi-part modeling, not just at the Part Studio level, but also when you go to create your assemblies. Okay, so moving on to my next example, and this is another example where you're building parts with contextual relationships to each other. Now, this is a bit of a twist in that we're building with imported parts rather than parts we've modeled. So this is another very common workflow. Let's say, for example, I've been emailed 2 Parasolid files. And these are 2 bottom and top casing parts, and I need to build a flange that joins those 2 parts. Right? So these are just some random Parasolid files that someone sent me, and now I've got to build a part around them. This is another example where we're working with multiple parts together. The key difference here is we didn't model the parts. They're imported parts from another system. How would we handle that? The first thing is importing. And I mentioned this briefly earlier. To import any file into your document, in the bottom left corner, under Create tab, you'll see Import. You import the file, just browse the file you like to import, it imports it, creates a tab for it. Okay, so it's very easy to import files into a document. Now, in this case, these are 2 Parasolid files, so it also automatically translates them. So here's the Parasolid file, okay, imported into a tab for the bottom casing, and here is a file, or here is a tab for the top casing. Okay, so again, these were imported Parasolids. I need to create a part that joins these together and then model a flange around those, right? So here's a blank Part Studio. The first step in this, and the main thing that makes this a bit different, is we're going to use a derived feature to insert the parts into this Part Studio. So I select derived, and I select the part I want to insert. Okay. It then inserts that part into this Part Studio. Right? So there's my first derived part. I'm going to do that one more time. This time, though, we'll choose the top case. Okay. So just keep in mind that you can insert other parts from other tabs into the current tab, into the current Part Studio. And the neat thing about this is now I've taken these 2 totally separate Parasolid files, brought them together into one space, and now I can build my flange. Right? I can use the faces of the imported models. I can constrain sketch geometry to them. So it's very easy for me to then go in and create the geometry I need to, okay, with respect to the original. So again, I don't have to take a bunch of measurements and figure out what the values are. It's very easy for me to just say, okay, attach this to the edge of the imported model. You can even take and convert or use the circular edges. So here's the edge here. I can just convert these to sketch geometry. Okay. Do a simple extrude. We'll extrude this 1/4 inch. And now I've built my simple flange. Okay. And again, the idea behind this is the main difference between this and the examples from before is we didn't model the original parts. We just imported them, and we used the derived feature to put them together in one Part Studio, and then I can build my model around them. Okay, so just another common example of, again, creating parts with dependencies to others. The main difference here is it could be a dependency to an imported model and something that you didn't necessarily model yourself. All right, so that is the derived feature, and another example of using parts with relationships to each other. Now, then the last example I have here for you is really using multi-part modeling solely as a tool. And I have an example of this, but bear with me. Real quickly, one question. Can you scale an imported part? Yes, you can scale it. You have the option to transform, and then you'll see scale uniformly. Okay? So just a tip for those trying to scale models. Under transform, their scale uniformly. You select the part, you set your scale factor, and you're good to go. Okay. So let's move on. Now, the thing I want to point out next is using it as a tool. So there are a few examples. I've already shown you briefly a few examples of doing it this way. But really up to this point, it's also been part of the design. So another quick question, can you scale from a point rather than a ratio? There is an option in scale to define a point to scale about. So forgive me if that doesn't answer the question, but you do have an option to reference a point in the scale option. All right, so I've mentioned before, and just briefly coming back to this, there's really three key examples that I had. Bridging is the first, and it's most common. You're just bringing two parts together. But then we have building parts with relationships to each other. Things like the clamp or the pneumatic cylinder, where I'm building all these parts relative to each other. And that's the most common multi-part technique. But the last one is building parts strictly for the purpose of being a tool, just to form or shape another part, right? So they're really like a temporary state. That's the way to think of multi-part modeling tools, is they're really just creating this temporary part for the purpose of later subtracting, adding, or whatever it may be to your main component. So an example I have of this is a U-bolt. And this is a great example because I may want to, treat the feature itself as its own entity. So I could maybe pattern it or transform it. So let me give you an example of this. Now, what I'd like to do is the thread for this feature. So we'll do sweep, and I want to sweep this triangle, of course, around the helix, okay, creating that thread profile. Now, by default, again, like I mentioned before, it assumes that you want to add, and you can, of course, do that. You can also remove to create a cut or cut the thread. But in my case, what I'd like to do is choose new. So what I'd like to do is create a whole new part that's only the thread profile, right? Just the 3D shape of the thread, right? Green check OK. And now you'll notice, if I hide part 1 here, there is a part that's nothing but a thread shape. Okay? And the neat thing about this is you can do a lot of things that you couldn't do otherwise. And one example would be something like a transform. Or I could do a transform by line, for example, and say, okay, transform this part by this line, right? And it will transform the part over. Right? So I can shift it over, for example. Now, of course, you could do this a number of different ways. One example might be something as simple as a mirror or a linear pattern. But it's important to keep in mind, with something like a transform, I can transform parts around. And I wouldn't be able to do that if it's only a feature. So the key thing here is you can choose new in your feature and build a part that's sole purpose is a tool. I can then transform or do whatever I need to do with that part and then later subtract it, right? We'll do a copy part here. So I have both. And so now I have two thread parts that I can very easily do a Boolean subtract and take the tools, right, and subtract them from my target. Okay. So again, just a different way of thinking about it, but the sole purpose of that thread part was just as a tool to later shape the model in some way. Right? So you can almost think of it as a temporary state, much like bridging, where you have several parts only for a period of time until the design is complete and everything has been subtracted or merged, whatever the case may be. So again, that's an example where you're using a multi-part solely for the purpose of a tool, and that's fine. That's another great example of multi-part modeling techniques. So that is what I had for you guys today. I'm going to stick around and answer any questions that you have. And just real quickly, going forward, one moment. If you're just getting started with Onshape, we really encourage you to try Onshape in your professional environment and let us know what you think. There's a feedback tool under the help menu in the top right. We really encourage you to give us feedback. Let us know what you think. Let us know if you see any issues or anything you'd like to see in the software. Really encourage users to give us feedback, and also share the model. There's a share icon in the top right corner. If you enter their email address, define their permissions, and hit share, they can be looking at the same model you are. So just keep in mind, it's very easy to share your document. They don't have to install or download anything. Most often they just click a link. So the last thing I want to mention is, if you're interested in establishing a user group, or maybe you're interested in meeting local users, we'd love to hear from you. We'd love to help you get things going. So I see a few questions. I will stick around and make sure that all of them are addressed, so bear with me. But that's it, everyone. Thank you and have a good day.